Hello, everybody. My name is Albert, and I work for Canva in the build team. And today I'm here to talk to you about Bazel promises, about determinism, and how they broke down in the real world. So Bazel has this thing called repository rules, which is kind of like its blind spot for reproducibility. Repository rules are allowed to depend on all sorts of things on the host platform. These things are usually the shell environment, the file system, and repository rules are also even allowed to do arbitrary network calls. So essentially, they become a huge hole through which the imperfections of the real world can sneak into your build and start causing some unexpected failures that are very hard to debug. So in this talk, I would like to walk through a few of the common issues that we've experienced over the years running Bazel and some of the mitigations we've tried to implement against these particular issues. So a very small example of a repository rule that it's quite typical that depends on an environment, a couple of environment variables, one which is very explicit just by reading the CI environment variable, and one that is a little less obvious to spot, which is through the which API, which implicitly depends on the system path. And from a quick look, there's nothing inherently wrong with this implementation except that as it stands, Bazel will fail to rerun it every time that the values of these environment variables change. And the reason for that is because in the current instantiation of the repository rule function, as it's at the bottom, we failed to specify and tell Bazel that there's this dependency on the path and the CI environment variables, and therefore Bazel forgot that it needs to track that value and then like rerun with those environment variables, and then rerun this implementation function when they change. So some of the mitigations that you can do against this is, if you can, and you're in control of the implementation function, and you're in a relatively new version of Bazel, you can use the getenv API instead of the old os.environment.get. This new API takes care of like tracking which environment variables you're accessing on your implementation function automatically, and therefore you don't have to remember that you have to also specify somewhere else and keep that somewhat in sync. Another approach that we've tried internally was to use the tools Bazel wrapper to try to narrow down and stabilize what environment do the Bazel client get passed on. And that kind of like initially seemed to work, but then we had a little bit of issues with rule sets that actually want other more esoteric environment variables that we happened to be filtering out. And the killer for this workaround was that engineers doing Bazel run some binary that also wanted some environment variables were also like getting like their environment stripped out, and then we were getting complaints that, hey, if I do this under Bazel run, it's not running, but if I do /Bazel bin, whatever the binary is, it does. So it was confusing for users. So it's not really like a very good solution. So we have a little bit of a work in progress, which is a contribution that my colleague Jordan is trying to push to Bazel upstream. It's quite close to landing, I think. And the idea behind this contribution is to give us a mechanism to declaratively specify what are the environment variables that we want to be accessible for repository rules. It will be rolled out as an opt-in, so you can choose whether or not you want this particular behavior. But if you opt in into that, by default, repository rules will only get to see the path or path and path X if you're in Windows. And then through the already existing flag, repo-env, you would be able to add on top of the environment variables that you want to inherit from the client, or even like set them to specific values, or even if you really, really need to have a mechanism to remove some of the default that gets inherited by default, and just don't do that if you wish to do so. Another example of a repository rule that can be problematic is those that access files in the file system and they don't declare them as inputs. So as I was saying, repository rules have full access over the host file system, so they can even do all sorts of things such as accessing absolute paths. Don't do that. And with that in mind, it's kind of like the same problem. If the contents of that file fails, Bazel have no knowledge about that change, and then the repository function will not be rerun. This is especially true in Bazel 8, where rule sets are now expected to watch files explicitly. And if you don't do that, then you will get into this unexpected behavior. So some of the mitigations, this is more like an informative mitigation. If you can anticipate which files you're going to read on your repository rule, you probably want to specify them as an input, so it's very clear that this file is being read. So it's kind of like an informative thing. But also, please, if you're implementing a repository rule that depends on a file, you really want to use the watch APIs so that you communicate to Bazel that you're actually reading that file and you're interested on tracking that if the contents change, you'll want to rerun the repository function. There's an equivalent called watch3 that is convenient sometimes to watch like changes to directories on files and their given path. And one thing that actually surprised us is that during the Bazel 8 migration, we weren't aware of this change in default behavior in terms of like the implicit watching that Bazel is doing in files. So we got like a little bit of issues with some rule sets, the repository rules. So one recommendation is that if you want to minimize that impact, you probably want to set incompatible no implicit watch label to false while you're migrating, and then remove it and maybe like adapt some of the rule sets that might be introducing issues, just to minimize like how many things change all at once. And finally, at Canva, we have private mirrors, which is basically caches for all the upstream dependencies that we consume. This is a pretty common pattern. And with this pattern, we actually hit a few issues in the repository rules scheme of things. The first one was actually a performance issue. So it turns out that upstream canonical repositories or URLs are generally geographically distributed, but our mirrors are not so geographically distributed. So depending on where the Bazel client was located, we have quite a distributed workforce. Builds were getting slower because downloads were also getting slower. So that was something that was a little bit surprising to us. We didn't anticipate that at the very beginning. And then configuration rot is another problem. Sometimes because you have caches, your configuration, something might change in the canonical sources, but because you have a copied cache of that, you won't only find out when that cache expires, which can be like days, hours, months after. So it will be hard to debug because of like the lack of correlation. So some of the mitigations here was for the download performance, we use the inbuilt Bazel URL rewriter, which in combination with the tools Bazel hook allows us to detect where the Bazel client is running and quickly like reorganize which is the priority of the mirrors that we want to use, and therefore like optimize for download times. One note on this, it only works for HTTP archive, HTTP files, and anything that is on top of like the repository context download functions. If you're doing repository context execute curl, that won't be caught by the rewriter, but that's a particular downside. You want to use canonical URLs because then you can easily integrate with Dependabot or things like this, and also it will make it easier to craft all these rewrite URLs because it's always like from canonical to mirror. And ideally, don't remove upstreams if you can, because you want this to be like an optimization rather than a requirement. So if your private mirrors, for example, have some downtime, your builds don't stop, they just get degraded. And finally, to try to account a little bit for like changes that happen upstream, but you don't notice until your caches expire, we actually try to develop some periodical checks on the upstreams that we remove, forcing to bypass, basically running Bazel continuously, bypassing our caches to validate that the configuration is still valid and detect when it's not as close as possible when the issue is introduced upstream. When you do this, you have to make a few trade-offs in terms of like how exhaustive you want to be with your testing, so how frequently you run it, how exhaustively you want to check all the mirrors, because it can have a noticeable impact on your cloud build, so be aware of that. But the way that we're doing it currently just depends on already existing facilities in Bazel, specifically facilities under the Bazel mod command, and then just a combination of a few JQ filters on top to extract the information we want. In this this particular case, list the repositories and extension repositories, get those ones that are HTTP file or HTTP archives, and then when we have all this list of labels, try to run Bazel with an empty output base or repository cache so that we exercise the actual downloads. So even though repository rules are never going to be as hermetic as regular build actions, because that's by design, I hope that with some of these mitigations and lessons that we've learned and that I'm sharing, we can help protect our builds from the chaos that the real world usually injects into them. Thank you.